Hello everyone, hope you are all well and that you're finding these videos useful so that you can understand better what we are doing. So as I told you, we have finished the topic of algebra, okay, and now we're going to start a new topic which is related to algebra, but we're not going really deep into the subject of sequences, so you might not recognize that we are dealing also with algebra. But we are going to talk on sequences, patterns and number machines. Okay, I will send you these notes, of course, as an attachment. Okay, so what are sequences? Sequences is a list of numbers, but they are in a certain way. The numbers are put in a certain way, okay, in order. They have order. So there are several notes here, okay, but I'm going to go straight to these sequences, okay, because I think that you understand better when I give more examples on numbers rather than words, okay? But these words, I mean, for example, if you have even numbers, odd numbers, they're here, triangular numbers, we have also them here, okay? But I mean, I recommend you to read them so that you can see what's going on as well. So these are some examples of sequences. For example, this sequence over here, which we have 2, 4, 6, 8 and 10, is an example of a sequence of even numbers. They are all even numbers, or what we call the multiples of 2, the 2 times table, okay, because even numbers are all in the 2 times table. The next sequence is 1, 3, 5, 7, 9. Of course, these are the odd numbers, okay. Multiples of 3, we have 3, 6, 9, etc. Okay, multiples of 3. Multiples of 5, again the 5 times table. The square numbers, a square number, let me remind you what a square number is. A square number is when we multiply a number by itself, the answer is a square number. So the list of the first square numbers are 1 times 1, which is equal to 1. 2 times 2, the number times itself. Okay, 2 times 2 is 4. 3 times 3 is equal to 9. I'm doing them in order. 1, 2, 3. So now it's 4. 4 times 4 is equal to 16, etc., etc. Okay, these numbers and all the others are called the square numbers, okay, are called the square numbers. And here we have 1, 4, 9, 16, 25, etc. Those are the square numbers. Apart from the square numbers, we have also the cube numbers. The cube number, a cube number is when we multiply a number by itself 3 times. So a sequence of cube numbers will begin with 1 times 1 times 1, which is equal to 1. 2 times 2 times 2, which is equal to 8. Okay, 3 times 3 times 3, which is equal to 27, etc., etc. So these are the cube numbers. These are the square numbers. Okay, so a sequence of cube numbers will begin with 1, 8, 27, etc. Now, here you have also triangular numbers. These are not very common, I mean, but it's here, so I will explain it as well. So when we start with just one dot, okay, we have only one dot. So the sequence will start with 1. When I add more dots so that I can draw a triangle, so I'm going to repeat this dot and add 2 more, so that I have a triangle. Okay? So I have added another 2, so plus 2. And then now I have 3 dots. So the sequence is 1, 3. The next triangle, to form another triangle, I'm going to draw the exact triangle that I already have. Okay? And now I need to add another 3. So 1, 2, 3. Okay? So that I can have this triangle. Now, together we have 1, 2, 3, 4, 5, 6. That's why we have 1, 3, 6. This sequence is starting to take shape. In order to continue the sequence, I need to draw this again, the previous triangle, and now I need to add 4. So here we have added 2, now we have added 3, and now we are going to add 4. So 1, 2, 3, and 4. Okay, and we have that triangle. So together here we have 10 dots. Okay, these are triangular numbers, but they are not so important. Okay, not so important. You can maybe remember them when you have logs. Okay, you can build logs like this. Okay, to add more, you will have to add these up. Okay, the spaces, etc, etc. But it's not that important. And now this is, in fact, we have 15 dots or 15 circles, so the next term is 15. Okay, but the most important are these sequences. Now let's talk about a sequence. Okay, let's talk about the sequence. So this is very important. Okay, hope that you are you can see it clearly. So a sequence, when we have a sequence like this, 3, 5, 7, 9, and then the dots, everything means something. So this one, the first number, is called the first term. Okay, we have written here first term. Okay, the second number in the sequence is called the second term. The third number is called the third term. The fourth term. And these dots here tells us that the sequence goes on forever. It's infinite. Okay, it does not stop here. We don't do a full stop, but we do a comma with 3 dots, which means that it goes on forever. Okay, so it's important, please, to realize that the first number is called the first term. So from now on, I'm going to use I'm referring to this number as the first term. Okay, I'm going to refer to the number 5 as the second term of the sequence. Okay, so this is the first term of the sequence, second term of the sequence, third term of the sequence, fourth term of the sequence, etc, etc. Okay, so that is important. Okay, now describing and continuing sequences. We have to be able to describe a sequence as well as to continue, of course, the sequence. So, for example, here we have 3, 7, 11, 15, 19, etc, etc. We can notice that the difference between the terms, okay, is always 4. So 3 plus 4, which makes 7. 7 plus 4, which makes 11. 11 plus 4, 15. 15 plus 4, 19, etc., etc. Okay? So each time we are adding 4. Okay? Each time we are adding 4. And the first term of the sequence is 3. Okay? The first term of the sequence is 3, and we are adding 4 each time. Second example, we have 22, 16, 10, 4, etc. So now, if we find the difference between the two numbers, we know that we are subtracting 6 each time. So 22 minus 6 is 16, 16 minus 6 is 10, 10 minus 6 is 4, 4 minus 6 is minus 2, minus 2 minus 6, minus 8, and so on. Okay? So these, in this type of sequence, we have started from 22, so the first term of the sequence is 22, and each time we are subtracting 6. When the sequence is increasing or decreasing in equal steps, for example here, we are always increasing by 4, always increasing by 4, okay? Here we are always decreasing by 6. When the sequence increase or decrease in equal steps, that sequence is called a linear sequence. Okay? It's called a linear sequence. So a linear sequence, just to repeat, is a sequence that from one term to another, it increases or decreases each time with the same amount. Okay, so either plus 2 each time, plus 2, plus 2, plus 2, or maybe decreasing, minus 5 each time. Okay, that is called a linear sequence. Other type of sequences is like these two here. So, as you can see, from 1 to 2, if we try to find the how much is increasing, here it only increased by 1. But from 2 to 4, it increased by 2. Then it increased by 4. Okay, then it increased by 8. So this is not called a linear sequence. Okay? Because it's not increasing the same way that these two are increasing. But we can notice that we are multiplying here. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16, and so on. So here we are starting from 1. So the first term of the sequence is 1, and we are multiplying by 2 each time. Okay? Second example, we have 1024, 256, 64, 16, 4, 1. So if we look to this part of the sequence, we can notice that we are dividing by 4. 16 division by 4 is 4. 4 division by 4 is 1. And it applies to the whole sequence. So 1024 division by 4, 256. 256 division by 4, 64. Division by 4, 16. Division by 4, 4. Division by 4, 1. Now, 1 division by 4 is 0.25. But normally in sequences we write it as a fraction as well. So 1 on 4. Okay, 1 division by 4, we write it as 1 on 4. Now, we need to divide 1 on 4, 1/4, again division by 4. So we have 1 on 4 division by 4. We have done this when we have done the fractions topic. Okay, when we are dividing, we need to write the first fraction as it is, 1/4, change the division to multiplication, and reciprocate. Okay, we find the reciprocal of 4, which is equal to 1/4. And then we multiply the numerators together, so 1 times 1 is 1, and the denominators together, so 4 times 4 is 16. So that is how we have achieved 1 on 16. So 1 on 4, division by 4, it is 1 on 16. Okay? Because of what we did in the fractions topic. Okay? When we are dividing by another fraction, we need to change the division to multiplication and write the reciprocal of the second fraction. I'm going to skip these because again these are not so important, but you can have a look at them, but it's not that important. Okay, let's move on to the next page. So the most important thing is that we have said so far is that the first number of the sequence is called the first term. Okay, it's called the first term. Second number is called the second term, etc., etc. They go up or down. Okay, the sequences can go up or down, both by adding numbers, okay, or decreasing numbers. Okay, when we are adding each time with the same number, we call that a linear sequence. When we are subtracting with each number, we call that also a linear sequence. But sometimes we multiply sequences, so 1 times 2 is 2, 2 times 2 is 4, okay? Or dividing. That is also, of course, another examples of sequences. So this is very important. Now, we have the term-to-term rule. What is the term-to-term rule? So we need to analyze a sequence, okay, to determine the rule. I have already mentioned the rule, okay? So, a term-to-term rule gives a rule for finding each term of a sequence from the previous term or terms. So, for example, if we have this sequence 1, 4, 7, 10, 13, 16, 19, you can immediately notice that we are adding 3 each time. Okay? So, the rule is that we are adding 3. That is the rule. But we must mention also the first term. Okay? Because if I tell you, write me a sequence by adding 3. Okay? From which number you're going to start? From 2, from 5, from 8? So I need to tell you, start from 1 and add 3 each time. Okay? So that's the rule. Start with 1 and add 3 in this case of the sequence. Okay? We're starting from 1 and adding 3 each time. To generate a sequence, generate means to write a sequence, okay? To write a sequence. To generate a sequence from a term-to-term rule, we must always be given the first number in the sequence, as I have already explained. I cannot ask you to write me a rule just by saying divide by 3, and that's it. I need to give you the first number of the sequence. For example, start from 27 and divide by 3 each time. That makes sense. That you can make a sequence. So, we have example. So, the first term is 5, okay? The first term is 5, so now we are going to start generating the sequence. We are given that the first term is 5, so we're starting from 5. And the term-to-term rule is add consecutive even numbers starting with 2. So consecutive means one after the other. And we are going to add each time even numbers. and we're going to start with 2. Okay, so the even numbers are 2, 4, 6, 8, etc. Okay, this is how much this sequence is going to increase. This is not the sequence, okay, but by how much is going to increase each time. The first term is 5, so I've started with 5. We need to add plus 2, so 5 plus 2, which is 7. Next, we need to add plus 4, and 7 plus 4 is 11. Next, we need to add plus 6, so 11 plus 6 is 17. To find the next term, we need to add plus 8, so 17 plus 8 is equal to 25. So you can see here that these are all even numbers, because we are told that the rule is add consecutive even numbers starting with 2. But now we're going to start with 2 and add, okay, so plus 2, plus 4, plus 6, plus 8, plus 10, plus 12, and so on. We have this small exercise here, okay. I'm going to work out 2 of them, and then I will leave the others for you. Well, so the first term is here minus 7, okay, minus 7. The term-to-term rule is add 3, so I have to start from minus 7. Minus 7 plus 3, okay, we are adding 3 to find the next term. Minus 7 plus 3 is minus 4. And we have to write the first 5 terms, okay? 5 terms, the first 5. Minus 4, add 3, so it is minus 1. Minus 1, add 3, which is equal to 2. And 2, add 3. Just add 3 each time, which is equal to 5. And there we have it, the first 5 terms. The first term is minus 7, second term is minus 4, third term, fourth term, and fifth term. Okay? I'm going to work out this one. So the first term is 3. The term-to-term rule is to double it. Mana 3, double 3 is 3, and 3 is 6. Double 6 is 12. Double 12 is 24. Double 24 is 48. And here we must do these dots. Okay? And that's it. So I'm going to leave the others questions for you. Okay? On page 4. This is on page 4. When you are watching this video, it's important that you either print these notes. If you don't have a printer, don't worry. You can split the screen on a computer. Okay, don't watch it on a mobile. I mean, split the screen on a computer. One side put the video, and on the other side follow the notes. Okay, so that you can follow the notes while watching the video as well. Let's continue, because question 5 is also on what we have done so far as well. Okay, so question 5, we have complete the number sequences. What is the rule for each sequence? For example, here we have 3, 6, 9, 12, 15, etc. The rule is add 3. Okay? Here we haven't wrote which is the first term. Okay? But if you want, you can write start from 3 and add 3. Okay? let's work some together, okay? And then I will leave it up to you. So here we have 8, 12, 16. So we are adding 4 each time. 8 plus 4 is 12. 12 plus 4 is 16. 16 plus 4 is 20. 20 plus 4 is 24. 24 plus 4 is 28. So the rule is add 4. Okay? The rule is add 4. Start from 8 and add 4. If we take, for example, the number 12, here we have 40, and then 60, 80. So these are the multiples of 2. So we have 20 here, okay, and then multiplied by 10. So we have 20, 40, 60, 80, 100, and 120. Okay, and we are adding 20 each time. Okay, we are adding, so add 20. I think that I'm going to leave it for you to work them out, okay? You have to check exactly by how much it is increasing or even decreasing, and then you need to write the rule as well. The next exercise on page 5 as well, okay, is skip counting. Fill in the missing numbers to complete the patterns. So, for example, the first one, we have 26 and then 22. So from 26 to 22, we have subtracted 4, so minus 4. From 22 to 18, we have also subtracted another 4. Okay, so from 18 I'm going to subtract also another 4, which is 14. 14 minus 4 is 10. 10 minus 4 is 6. So again, you have to just check by how much it is increasing or decreasing, and then continue the sequence. Let me work out this one as well. So we have 14 and the second term is 19. So we are adding plus 5. Okay, so 19 plus 5 is 24. 24 plus 5 is 29. So today's homework is to try out from page 4 this exercise. Okay, page 4. You are given the first term and the rule. Okay, so always start from minus 7. Here you're going to start from 100 and then subtract 8 each time. Here you're going to start from 0.04 and then multiply by 10. Okay, that is on page 4. And page 5, the whole page. Okay, the whole page. Tomorrow I will give you the answers. Tomorrow's lesson is about sequences as well, but we're going to work pictorially, okay, with pictures. So we're going to add some, for example, this one is about matchsticks, okay? So we're going to add some matchsticks so that we can continue the pattern, okay? Hope that you understood today's lesson. That's all from me today, okay? Always take care, stay at home as much as possible, and do your homework. Ciao.